Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Matthew Austin, a physical scientist with the National Oceanic and Atmospheric Administration, where he is involved in the Coast Survey Development Laboratory's Cartographic and Geospatial Technology program. Matthew has been leveraging FME for the past 7 years to support nautical charting and hydrographic surveying.
Here's an outline of my presentation. I'm going to give you a history of NOAA hydrographic surveys, and then go on to ways that FME Workbench helps streamline hydrographic survey data management, and then go into ways FME Server helps with hydrographic data delivery. I was going to do an FME Server demo, but due to security restrictions, I'm not going to be able to show that to you, but hopefully I'll be able to show you some Google Earth output from FME Server. So let's get started. About NOAA Coast Survey. If you don't know, NOAA is the National Oceanic Atmospheric Administration. And I work in the Office of Coast Survey. NOAA surveys, our mission is to survey U.S. coastal waters and deliver up-to-date information for updating nautical charts to promote safe navigation. You can see this is the area of U.S. waters. So to begin with, surveys started around in the 1850s. Lead line was the first technology. So you basically drop the line and figure out how deep it is, and that is the individual sounding measurement. Things got a little bit more sophisticated with mechanical sounding system. You can see casting for the lead line. Let's see, and then in the 1930s, the fathometer was introduced. I'm not a hydrographer, so if you ask me any specifics about this technology, you'll have to ask someone else. I don't know if Kyle, he also works for the Hydrographic Surveys Division. He might have some answers for you. And then we have, let's see, I think it looks like I'm missing a slide on single beam technology, but here's the multi-beam. That was before multi-beam technology, which was introduced in the 1990s. This is showing historic soundings. Soundings are the spot and elevation. If you have any questions about what soundings are, let me know. The historic surveys, which are the dots that you can see, and then there's the modern. You can kind of distinguish the difference between the two. So this is our workflow. We have our older surveys, which are Smoothsheet density. So this is vector point XYZs that we're pulling into Oracle. Then we have bag surveys, which previously were not supported by FME, which in FME 2010 will be. And then we basically want to process this bathymetry and output it to a product scale. So this would be for automating sounding selection for cartographers. This is showing the coverage that we have. You can see all the red areas, so that's data from lead line, which is our oldest data, but you can see all the data gaps that we have for surveys. You can see that there's quite a bit of old data. A lot of people don't realize that a lot of the data that's on a nautical chart is old. There's certain charts that actually have soundings from the late 1800s. And everyone thinks that, you know, the data is high quality data is available for everywhere, but it's not really. And then, you know, it's just zooming in, and you can see a little bit more of the coverage. You know, the green would be the newest, which is very small, of course, and then, you know, the single beam and multi-beam. So a lot of what Kyle works on is developing the hydrographic survey priorities. So that's basically trying to cover up the areas where most of the boats go that we have old data for. So this is just showing the various regions of the US, the coverage that we have, and Chesapeake Bay, Southwest, Seattle. You can see that we've surveyed closer to like where ports are, where there's a lot of high ship traffic. Those are the primary survey priorities. So the old official hydrographic survey deliverable, I've already talked about. This is the Smoothsheet. This is actually what was delivered to the cartographers to select soundings from. So since this data goes back quite a ways, the Smoothsheet was actually a printed copy. Like these used to be created on ink and mylar. So the older surveys we are actually digitized. So we have two categories of data, either digitized or for newer data, we actually have the digital data. So in the digitizing process, there's, let's see, let me go on. So we have a lot of different data sources for this historic data. We have mapped info tab, microstation, design file, and we're really dealing with a lot of disparate data sources here. Certain contractors would have soundings on different levels in the design files. In some cases, features would be on cells. It's different, and even in text files, coordinate systems, there wasn't a consistent standard. So using FME Workbench, we used FME Workbench to standardize this and pull the X, Y, and Z from these disparate data sources. So this is zoomed into a Smoothsheet survey design file, so you can see the individual soundings, just to see what that is. And to do this, we use FME Workbench to either read from the levels in the design file to extract the soundings to a shapefile before we loaded it into Oracle. So we did various QC on the historical surveys. So I've already spoken of the types of some of the errors we've had, like digitizing, depth outlier, and we also had positional outlier too. And in many cases, some people got a little crazy with the digitizing. There was one sounding XY location where there was 6,000 soundings. Yeah. Yeah, there's about 6,000 Smoothsheet surveys, so that's about 80 million points that we have in one single database. So since a lot of this data was digitized by students, it's really kind of hard to figure out where these errors lie. But here's an example of the Smoothsheet digitizing error. Students digitize this. You know, this would be 40 feet as 0. So we're still working on figuring out ways to calculate these outliers using statistics and but an easy one with FME was for figuring out the horizontal positional outliers is just by doing a convex hull around the survey. You can see that outlier was easy, you know, by just generating convex hulls, you could tell which soundings were wrong, and we were able to just flag them and turn them off. Let's see, so also because we didn't really have good polygons or survey outlines, because these outlines were generated by the students at the same time that they were digitized, so they didn't really reflect the bounds of the survey. So we used FME to convert the data to UTM, and then we buffered out, and then we buffered in, and then we reprojected to UTM so that we get a tight fit polygon. We still had to manually edit the output polygon, but at least FME provided something that would give us a good starting point for the editing. So this is the workspace. So we're basically reading from the Oracle sounding table that had 80 million points, and then we're joining to a table which has the UTM table that corresponds to the survey. And then, let's see, it's been a while since I've looked at this, but we're basically doing the same thing that I just described. We're buffering in, and then we're buffering out, and then we're outputting a shapefile which gets edited. That's the last part of the workspace. So ideally what we want to do with this data is create a single layer which has the best available sounding data. So but once the first step was to generate the polygons, then we can simply do an area on area overlay so that we have like a cookie cut of the best available sounding data. So that's what this Workbench does, just by an area on area overlay, doing the cut by the end year of the survey. So this just kind of, I'll give you an example. Like for this area, you can see the first surveys were done in 1919 for this area, Hampton Roads. And you can see that, well, that's a lead line. Then single beam in 1920s and 1930s. There's 1940s. So you can see these are pretty complex polygons. And then finally, the newer survey that affects this chart. Okay, and then to generate the soundings, because we already have the data in Oracle Spatial, we just create a table by selecting the soundings that fall within the superseded polygons by the survey ID. So that's the old data that goes up to about 2007, or ends around there. But the new official NOAA Hydrographic Survey deliverable is the BAG, which is the Bathymetric Attributed Grid, which, like I mentioned before, is now supported by FME 2010, which will be really useful. And we were using a product called CARES, which we currently do for generalizing the BAG data to a nautical chart product scale, but I think we might be able to do this with FME now. So this is an example of what a BAG survey looks like. It's a raster data format, and the metadata has XML embedded. I think the US is the only hydrographic office that's currently using this format. So, so here's what we're planning to use FME Server for. We have a lot of disparate data sources. We have our survey tracking system in SQL Server. We have our sounding data in Oracle 10G and Oracle Spatial. We have our BAG data, which now thankfully FME supports. And then we have our metadata database, which is an Oracle database, which is at the National Geophysical Data Center, which is in Boulder, Colorado. But now, using FME Server, we can link these disparate data sources to ensure so that we can get, the view that we want based on our business process. So we're also, planning to use FME to work with the cartographers and try to develop requirements, say, for sounding selection. Okay. So we also want to use FME Server to provide data to internal and external customers, which, it's really easy for them to choose their area of interest, select the data that they want, or do a filter, and download the data. So here are data sources, which I just talked about a little bit. So here are some of the ways that we're planning to use FME Server. Just like I said, area of interest, download by chart. This is we have different types of users. We have internal and external, but being able to filter by chart, survey ID, and processing method would be really useful for internal users. I found it was really useful to send published parameters to the Oracle where clause. And if you actually use an inquiry, so you could select an individual survey ID or a locality and do the filtering before you bring the data into Workbench. And